Swayam Prabha. Digital India. Educated India.
What does it mean actually? So this is a slower going function than this function for large values of n. Okay, that's the overall idea. Asymptotic notation means up to your level for the timing is like this way that this function, the all functions in this collection of functions, this is a class of functions. Every function here in this class is a slower going function than any function in this class for large values of n. Okay. This is a collection of functions, this is a collection function, and then any function you take it here, that will be a slower going function than this function for large values of n. Fine. So now question is that, okay, can I sort n integers with a different strategy so that this will run in this time complexity? There are at least three, four algorithms are there. So which one I should do quickly? Okay. There is a question. Okay. Suppose this is an array A. It has n1 elements. I have another array, n2 elements. This is called B. Okay, two arrays are given to me. One having n1 elements, other one having n2 elements. Okay, and this is also, I assume that this is sorted. And this is also sorted. Two different sorted arrays are given to me. Fine. Can I merge them to a new array called C from first location to length is n1 plus n2, such that this is also sorted? Okay, I am asking a question to you. And if you don't answer, be relaxed. Fine. If you no answer, also you relax. Fine. Why I am saying like this thing is that if you wanted to improve the time complexity significantly, then you have to think in an entirely different way. It should come in a new idea. Okay, and hitting that new idea is not always easy. You have to get into the problem and then try so many things. Somehow something will come up, provided it exists. If it doesn't exist, then you try like anything, you cannot hit it. That difficulty is there. Maybe some other time, some other place you will see it. Okay, so this is the question. That it's a new thinking. Okay, some new question that one sorted array A1 is given, A is given, another sorted array B is given to you. Can I merge them to a new sorted array C efficiently? I am adding one more word called efficiently. It means that, okay, what you'll do, if I don't know anything, what I'll do, I'll just merge it, take it there here, take it here, remaining part, then apply the bubble sort. That can be done. Because we have already learned what is called bubble sort. Okay? There is a strategy that you take first n1 elements here, copy it directly, second n2 elements, keep it there, and the next append it at the end, copy them, and then this is need not be sorted, and then apply bubble sort algorithm here. Fine? So that will take order of n1 plus n2 square time. Fine, because you are applying bubble sort algorithm on this number of elements, which is n1 plus n2. Okay, so you will get quadratic time complexity. That's a bit expensive, perhaps, because we are saying that okay, n square is a bit expensive. Can I improve it a little further? Okay. So this strategy will not help me to get into this thing. Okay. But then what you are trying to do, you are not using the fact that this is sorted and this is sorted. That information you are not using. Okay. If you are using bubble sort algorithm there. Okay. So what you should do is that can I do it in linear time? Can I do it in linear time? Which is better than quadratic. Okay. So what you'll do is that, okay, you try to see this element A1, maybe it is B1 here. You compare these two elements, whichever is smaller, push it here. Fine. Suppose this is smaller, you put an index I, maybe you put an index J here, and you put an index K here. Okay. Compare these two things, which is smaller, push it here. Okay. Suppose this is smaller, then I extend this index to next element. This A1 comes to here, and this index goes to the next cell. I am using the fact that these are sorted. So first element here, you compare these two things, which is smaller, come to here, and that index goes up. And this index, this is filled up, so index is going there. Then next index here and next index here, compare this thing, which is smaller, push it there. Fine, that's the strategy. You are using the fact that this is sorted and this is sorted. Okay. So what will happen this time that, okay, this index is always increasing in this direction. It is just coming back. Fine. It is always increasing this direction. This index is also always increasing in this direction. And this index is also increasing in this direction. So that will help you to say that this runs in linear time. So the moment everything comes here, then it is already sorted. Is it okay? I am not writing the codes and all this thing. This is basically what I am saying, that this is a software, there is a code I am saying. Merge, yeah. Sorry, let us write in this, okay? A and B. I am not writing on the type, it will take time from me. Idea is like this way. You fix an index here and fix an index here and fix an K index here, compare I and J. So you compare with AI with BJ, whichever is smaller, put it here and increase the corresponding indices. Right. So those who are smaller elements, they will get filled up in this way. Okay. So some careful things have been done, but it will be done in linear time. So this runs in order of n time. Fine. Merging two sorted array to get a new sorted array, I can do it in linear time. Fine. I have not shown the code to you. You can find it out. Don't worry. How do I use it for sorting n integers? Okay, that is also a slightly different way of thinking now. Okay, so what you can do is that, okay, okay, I have to erase this thing. You have started with an array of n elements. You have started with n elements. Okay. I am right now I have expertise in merging two sorted arrays to a larger sorted array. Fine. Laziness. Once you become intelligent, then you become lazy. Everything you want to think in that way and save your time and get out somewhere else. That is called intelligence. Intelligence makes you lazy. I'm following that thing now. Okay. So this is n integers, 1 to n. I have to sort them. Okay. What I'll do is that I'll divide into two parts. Okay. I'll roughly say n by 2 roughly n by 2. N is integer, divisible by 2 or I don't know. So the floor function you take. So this is my roughly n by 2 objects. Roughly n by 2 objects with 1 unit difference. I'm fine dividing like this. So again I will do it subdivide. Fine, n by 4. This is getting smaller and smaller, but I am not doing sorting. I am just subdividing. Okay? Clear? So at the end, I'll have singletons. These are all singleton objects. N objects are there. Okay? Singleton objects are always sorted. Very trivial thing. Very simple observation that singleton array having only one object is always sorted. You don't need to think about it. Okay, I'll use this idea of something called termination criterion for writing a recursive algorithm. I'm heading for a recursive algorithm. Okay, so I'm trying to use something called termination criteria. What does it mean that? Okay, I am subdividing. At some point, I'll just stop. No, don't do any further. Conditions that if these conditions are satisfied, stop there. So condition here is that when it becomes a singleton array, singleton object, don't sort anymore. It's already sorted. Fine. Okay. So now you are convinced that okay, these singleton n objects array, n individual arrays of each one of length 1, they are already sorted. Fine. Okay. Fine. Now you code it back. Go up. Here I am using my expertise of merging here. This is sorted. Apply the merge algorithm and get up.
Sir, but those n separate data sets will be sorted only if the main data set is sorted.
No. This is not sorted.
So then how will the separated n data sets be sorted?
I'm saying that a different array, new array have designed, constructed. This is not A.
Sir, but how does that guarantee that the new separated array is sorted?
This is not sorted yet. At this point, this is not sorted. At this point, it is not sorted. When they are having singleton, they are sorted. At this level, they are sorted. Okay.
Splitting them also takes processing time now.
Yes, obviously.
But is it linear?
We'll see that thing. We'll come back to that thing. That's a good point. You are splitting into 2 parts. You have to spend time. Fine. That has to be accounted. Correct. Okay, we'll come back. So these 2 are sorted. So I am expert in merging 2 sorted arrays in a larger array which is sorted. I am expert in that way. That I can do in linear time. So I apply here these 2 things to merge into a larger array in linear time. So at this level, everything will get sorted by the going up. I have subdivided, I'm down. Bottom level, everything is singleton, already sorted. Trivially, they are sorted. Now I am going 1 level up. So these 2 I will merge to get a sorted array here, like this way. Then again, we'll have something. 2 things will merge it to something. In linear time, I will get a larger array of 4 objects.
Sorting of all the single arrays take place simultaneously or to take separate tests?
Separate time.
Then it should be accounted.
We'll account. What happens is that, okay, what I'm trying to spend a lot of time here is that if I understand the mathematical, what is the way of doing mathematically, logically what you are doing, Out of that logic, I should write a code for that thing. Then the correctness of the code will come. Whatever you are saying is correct, you are absolutely correct, we'll account it. Keep it in mind. We'll account everything. Fine. So, in this level, they are by default they are sorted. In linear time for each one, I am taking linear time and getting merging into that is all sorted. I come up to next level, one level up. Then again, these two things merging to get one level up like that way. So I will go off like this thing. Sorry, I should use some different color. Okay. So I'm going up to get it sorted. This is sorted. This is sorted. Merging them, get it sorted, and then I'll merge it to get sorted away. Actually, I'm not sorting. I'm merging them. Okay. So this is called merge sort. Okay, and basically it is a recursive algorithm. Okay, so what we'll do, okay, what is the code now is okay, so yeah. Okay, so some technicalities are there here right now. What I'm saying in general, I'm saying that my array A is something here. I'm saying pth location to somewhere n is there, somewhere 1 is here. After some time, somewhere n is there. I'm writing in general from sorting from pth location to rth location. But I can call the function with first location to nth location. Okay, fine. So here I assume that I am sorting from the pth location to rth location of array A. When you actually call the function, you will call from A1 to n. Okay, fine. How does it look like? Fine. I said that okay, termination criteria should be done. When you are writing a recursive algorithm, you should go for the termination criteria first. And that comes from the simple observation. What is that thing? That if P is less than R, then do something. P is less than R, strictly less than R means at least two objects are there. So you need to sort. Okay. If P is equal to R, then the singleton is there, you don't need to do anything. That's the termination criteria. Okay, I'm fixing this logic, this gate or whatever comparison I'm using here is just to say termination criteria of my recursive algorithm. At least two elements are there, then do something. Fine. So what I have to do? Okay. So yeah, what should I do? Okay. Okay, fine. Recursively call it as A from pth location to, oh, sorry, I have to do something. He was saying that some accountability has to be done. So my, okay, P is equal to midpoint of P and R. Midpoint of P and R. How do I find? P plus, let us take a floor function. Okay, so then merge set A from pth location to, sorry, this I'm saying Q, I'm saying it's Q. P to Q, and this, that means saying, okay, you have the here to here, you try to do is pth location to qth location, this is q plus 1th location to rth location. You recursively sort this part and recursively sort this part, then you have to merge it. Okay, so that is doing, I'm just thinking that, okay, first I'm doing recursively call on this sub problem, smaller problem of n by 2 roughly size. You sort them recursively, Then you sort Q plus 1 into Rth location. Recursively I call it. Then I am recursively solving, sorting this part. Once these two parts sorted, then I will merge it. So you write the merge A from Pth location to Qth location, Rth location. That's the recursive algorithm. It takes time to get into that thing.
Sir, how does this work if n is not divisible by 2? How will you, if you're keeping it as a float function, how will you end up with 0.5 of an element?
No, this is floor function. Floor function. If it's 3.5, then it's 3.
Then the fourth element will go to the next.
Other side, it will go to other side. That's why I'm saying Q plus 1. Huh. Roughly around midpoint. I'm saying this is the midpoint. So here I'm taking from Pth location to Qth location. That's the first subpart. That's the first subpart.
So essentially it's marking the points.
Yes. Yeah, there is a hidden thing within your question. I didn't answer your question actually. But I just said yes. What happens here is that when you are writing a recursive code, the compiler actually creates an activation record. Activation record. That's a technical term. That's why I'm trying to avoid it. Okay. So when you're saying this hap and this hap, so I have given an impression at the beginning when you're asking question that okay, this is entirely different than this thing. This is entirely new array than this thing. This is entirely new array than this thing. In the recursive call, the compiler takes care of that thing.
So we don't have to do it.
You don't need to think about this thing.
The
Compiler takes care. Actually, it keeps into copy into separate thing with a time stamp or something in which recursion call it came. There is a stack is maintained, activation record. So Tower of Hanoi, when I was saying before the break, with n is equal to 60 plates, then the activation record becomes so high that you don't have any memory for that thing. Okay. So actually the compiler creates new copies of that thing with a different timestamp. It keeps track of which recursion is coming. You don't need to worry about that thing. Physically, they are different copies. Yes.
So is merge sort like the more efficient algorithm considering it's a bubble sort selection system?
At present it is yes.
But then, okay, sir, I have a doubt. For example, let's just consider 4 single-step arrays, 1, 3, 4, and 2, in that order. So when we merge sort them, we will get 1, 3, and then 2, 4. Then when we again merge sort them, we should be getting 1, 2, 3, and 4. But then in order to merge sort that, aren't we performing like bubble sort by itself?
No. That's why I said that, okay, in the merging algorithm, what I have done. You keep an index here, index j here, index k here. You are comparing these two things, whichever smaller is coming here.
Yes.
That is entirely different than bubble sort.
Yeah, like I didn't mean like bubble sort, but like aren't we like performing like another like additional series of sort?
I'll come to that thing. He's saying that this part they say okay, division time, subdividing time. Have you acquainted this accounting or not? I said yes, we'll do it. You are saying merging time, have I accounted or not? Yes, we'll do it. Fine, we'll do everything. Okay. So this is something. This is okay. Repeat it again. That this comparison is meant for termination criterion of the recursion. Fine. This is the time for subdividing into 2 subproblems. Fine. 1 addition, 1 division, and then floor function. Maybe 3 or 4 operations are done. Constant time. Fine. addition, division, and floor function. Maybe that you can write in a different way, so that you can be some constant number of operations, maybe 10 operations you can say. If you are not satisfied, 20 operations. That floor function you want to write in a different way. Let it be 20 operations, but it's a fixed constant. Okay? Then you are recursively calling this thing. You are calling recursively the same function with different parameters. If it has n elements here, this is roughly n by 2, n by 2. Okay? That's very important. And this merging takes linear time. If it is n by 2, n by 2, this merging takes linear time. Then how do I say the time complexity function? That I said T of n for bubble set is order of n square. How do I account it here? It looks very messy now. Okay? That messy part, put it in definition. Okay? So, what I'm saying here is that if it has n objects here, if there are n integers are here, let us say the time complexity for running is T of n in worst case. All complicated things I put it in the definition of T of n. Fine? Okay? So what is this thing? This is equal to some constant time if n is equal to 1. If there is only one element here, you don't get into that thing. Okay? Is it okay? If the P is equal to R, that is a singleton element, you don't need to sort anything, it doesn't get into the if statement. And it comes out. Fine? So that's why I'm saying if n is equal to 1, it takes some constant amount of time. System will call for if function and then you'll take one comparison, then you'll return yes, true or false. A lot of things are there. So that is a constant amount of time, small constant, maybe 10 units, 20 units, fixed depending on your compiler.
So separately it will take time to divide and separately it will take time to merge as well.
I'll come to that thing. I'm coming to that thing. Okay. But if n is sufficiently large, more than 1, how do I write this thing? Okay. So this is equal to, so if it is more than 1, then this time, I'll leave it for some time. This takes T of n by 2. Maybe if you are very strict, floor function plus T of n by 2 ceiling function for this guy. That will be q plus 1 to r. One of them is bigger, one is smaller, 1 unit. Okay. Plus this time some constant. So if I say small constant c1, this is linear time for this guy. Some different constant c2 times n. This time also I have to account. This is some kind of constant amount of time. C3, some constant. If n is greater than or equal to 2. Fine? Everything is accounted. Subdivision time, merging time, everything is accounted. Fine? So this is a recursive function, recurrence function. This is a recurrence relation. And this recurrence relation comes out of this algorithm. Correctness of algorithms comes from the mathematical understanding. What I am doing actually. Subdividing, and merging. Once I merge, gone up one side, that is sorted. That's sorted. Finally at the end it's sorted. So this is the recurrence relations. Okay? Any solution, any function which satisfies this recurrence relation is a solution for this thing, and that's the actual time complexity function. So left hand side you have T of n, function T is there. Right hand side also you have T. I want to get rid of T from one side. That is the actual function. Okay, I wanted to write T of n is equal to something here which Tn or T of n1 or n2 should not appear on this side. That is a solution for this reconciliation. Okay? Now question comes, how to solve this reconciliation? Okay. Then maths people are horrible at that time. Maths faculties are extremely horrible. They just make some kind of nice assumption and then get out of that thing. My terminology, beautification. The beautification is that this floor function and ceiling function is causing problem to you. All these extra things are coming in. Let's get rid of this thing, kind of thing. Beautification, let us do beautification. C1, C2, C3, why so many constants? Get rid of that thing. Okay, so what I am trying to write it down is as equal to C, let us say C, if n is equal to 1, otherwise I'll say, okay, my function, my n is a very nice looking function is of the form 2 to the power k. At that time the maths people are horrible. Okay, I am one of them. Fine. I assume that my n is of the form 2 to the power k. If I assume like this thing for some integer k, then this floor function, ceiling function will go away. At every level is even number, every level even number. Fine. Okay. Maths is actually simple, but it creates a lot of uncomfortable impression that, okay, why are you doing this thing? If you don't know the answer, then it creates problem. So this I will make for the time being the assumption that, okay, the number of integers given to me is of the form 2 to the power k. The assumption is made only because of the fact that I should get rid of this kind of floor function will never come to picture. Life is somewhat simpler. Let us do this job with that simplicity. Okay, if once you assume like this thing, then this becomes 2 times of t of n by 2 plus some constant times of n. These two looks almost similar. It becomes, this is 2 times of n by 2 comes to the picture here. Fine. Under that assumption, we'll see after some time how to get rid of it. Okay, a lot of joke. Yes. Yes, it's some other constants, but I am doing the beautification. Same constant, little bit larger constant le lo. If it is 5, 10, 45, let me make it my constant, everything C is more than 50, some fixed 55. Fine. Maths people are really, really horrible at that time. Okay. No. You don't accept it. Sorry. Okay. So this thing, how do I solve this thing? Okay. So I have erased certain things that anything was there, n by 2, then further down. I'll read out the picture again. Okay. So I'll erase this thing. Okay, so I have, there's a dot for Tn. I'm putting a dot there. I'm creating a structure now. I'm putting a dot means Tn. I will apply this formula, this definition, to replace it by something else. Okay, so this is C of n, this is T of n by 2, T of n by 2. I am using this recurrence relation. Basically, I am saying that this Tn is equal to sum of these 3 objects. Okay, fine. Assuming that n is sufficiently large. Okay. Now I will expand this thing by recursion. Okay. So next level what I will get? This is my Cn. This is Cn by 2. This is T of n by 4. All are T of n by 4. Okay. I applied the reconciliation here. Tn by 4, Tn by 4. I apply the recurrence here, Tn by 4, Tn by 4, assuming that n by 4 is larger than 1. Okay. I'll continue like this thing. At the end, you will singleton. Okay. So finally, what will happen is that I have so this is sum up to Cn. This sum, this Cn by 2, Cn by 2, Cn by 2. So this sum up to Cn also. Okay. Cn by 4 was there. So this is also add up to Cn. Okay. So at the end, I have n objects, which is equal to the power k. Each one is singleton. For each singleton, I am using the same C amount of time. Fine. So we will add up this label wise. This is also Cn. C times of n. Each label wise I am adding, it is coming to Cn, Cn, everything is Cn. Okay. Now sum of all these values is equal to sum these values. This is the principle double counting. I am counting one object with two different ways. So they must be same. Okay. Fine. So this is, but then question comes, what is the height of this thing? This height is k because of 2 to the power k. Is it okay? Fine.
Sir, what if the number of elements in this array is not a power of 2?
That's what I'm saying. Maths people are horrible. They always make beautification and then do it and get away from this place. Yeah, I can't say a joke, but I cannot have time to do that thing. I think you people are all hungry. The basic difference between engineers, mathematicians, and physicists. They are philosophically different characters. Okay, fine. We'll see after some time. Okay. So this is this height is k. K labels are there.
Could there be k plus 1?
ठीक है, no problem. Take it. Take k plus 1 if you are not satisfied. The teacher is maybe wrong. Basically saying that I have not done the homework nicely, could come here.
So I was thinking because it plays like 2 power 5 on top. So 32. So 32, 16, 8, 4, 2, 1.
ठीक है. Additional 1 unit is not a big issue for me. Okay. So coming back to this thing, okay, he's saying something. So if you don't assume this part, if you don't assume n is equal to the power k, so this will be it is log base 2 n. Some constant time something will come. Some different constant, maybe C prime. It will be like that way. If n is not exactly equal to the power k, then the height is of order of log n. So whatever constant 1 unit, everything get observed with this asymptotic notation. Okay? Fine. So the height is order of log n. Some constant times of log n. So these are the number of objects here, Cn is equal to some constant times of log n. I am not assuming now n is equal to the form 2 to the power k. So this sum is equal to some constant times, maybe C prime, n times log base 2n. So this is equal to T of n. Because initially I have Tn like this thing, I am expanding. I am using the recurrence relation and to get it that thing. Some of these objects are written in this. This is called tree recurrence method, tree generation method. Okay, so at all sum of all these integers is equal to sum of this integer, that is equal to c times some c prime times n log n. So your solution to this system is Tn is equal to so it runs in order of n log n time. Okay. Actually, you are not sorting, you are actually merging. Fine. So this is better than quadratic. Anything else you want to say?
Sir, but then like recursion takes up more memory than.
Yes, that's acceptable.
But like, for example,
Yes. So they say yes. These computer science people are really, engineers are really horrible. Okay, you wanted to become engineer also. They always trade between two things, time and space. If you want to relax space, perhaps you will gain the time. And if you are control the time, then you have to maybe more space. If you are decreasing the space, then your time will be more. So here, that's why I'm saying mathematics people are crazy a little bit. Okay, I want to decrease the time complexity like anything, log n. Memory is going up because of the activation record and the algorithm what I was writing, which is a recursive in nature. But theoretically, it says that it's much better than that thing. Anything else?
so like in conclusion, resource bound computation, you have to compromise on one.
Now both are within range of the our threshold of memory and time. But if you want to further decrease it, and then maybe your memory space will be more, you will occupy more memory.